Today's topic will be on solving geometry applications with a focus on triangles in today's lesson. So triangles have three sides and three interior angles. Usually each side is labeled with a lowercase letter to match the uppercase letter of the opposite vertex. The plural of the word vertex is vertices. All triangles have three vertices and they are named by their vertices. So this triangle is labeled triangle ABC. The three angles of a triangle are related in a special way by their sum of the measures equals 180 degrees. So we read the measure of angle A, that symbol, as the measure of angle A. So that M and then that little symbol A is read as the measure of angle A. So in triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. Now, because the perimeter of a figure is the length of its boundary, the perimeter of triangle ABC is the sum of the lengths of its three sides. So the perimeter is equal to the lowercase a plus the lowercase b plus the lowercase c. So to find the area of the triangle, we need to know about its base and height. The height is the line that connects the base to the opposite vertex and makes a 90-degree angle with the base. So the formula is 1/2 BH, where B is the base and height is H. So H is the height. Let's take a look at an example. The measures of two angles of a triangle are 55 and 82 degrees. Find the measure of the third angle. So we're going to read the problem and make sure it's clear what we're looking for. We're going to draw and label with the given information. So then we identify what we're looking for, which is the measure of the third angle in the triangle itself. We're going to name what we're looking for, and we're going to let x equal the measure of the angle. We're going to translate this into an equation. So we translate this into the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. So we fill in the missing values here. So 55 plus 82 plus x, which is the missing value, is equal to 180. So we're going to solve this equation. 55 plus 82 plus x is 180. So we're going to do simplification, and we get x equals 43. We're going to check this answer by substituting it in for x into the original equation that we developed, which will be 55 plus 82 plus 43 is equal to 180. And it matches. So let's answer the question. The measure of the third angle, the measure of angle C, is 43 degrees. So let's recap the properties of triangles. So for triangle ABC, the angle measures is the measure of angle A plus the measure of angle B plus the measure of angle C is all equal to 180 degrees. So the sum of the measures of the angles is 180 degrees. Next, we are going to look at perimeter. So the perimeter is the lowercase a plus the lowercase b plus the lowercase c. So the perimeter is the sum of the lengths of the sides of the triangle, which is usually denoted by the lowercase letters. And finally, we're going to take a look at the area. So area equals 1/2 base times height, noting that b is the base and h is the height. Next, let's take a look at the Pythagorean theorem. So with knowing what we already know, in any right triangle, a squared plus b squared is equal to c squared, where a and b are the lengths of the legs, and c is the hypotenuse, the length of it. So to solve exercises that use the Pythagorean theorem, we will need to find square roots. We have used the notation, the square root of m and its definition. So if m is equal to n squared, then the square root of m is just simply n. for any value where n is greater than or equal to 0, because remember, we cannot have a negative square root. It is considered undefined. And now I understand that this may be a little bit confusing, so here in a minute you can pause and kind of take this in. But first, let's take a look at an example of that. We find that the square root of 25 is 5 because 25 is equal to 5 squared. So 5 times 5 is equal to 25. So if you take a look at the if m is equal to n squared, then the square root of m is n for any value that n is greater than or equal to 0. So if you connect those two dots, you can see that that does indeed make sense. Let's take a look at an example. So we are going to use the Pythagorean theorem to find the length of the hypotenuse shown below. We're going to read the problem and make sure it's clear of what we're looking for. And we're going to draw and label with the given information, which it has already done for us. We're going to identify what we're looking for, which is the length of the hypotenuse of the triangle. And we're going to name that. So we're going to let C equal the hypotenuse. We're going to translate this into an equation, which is just our formula a squared plus b squared equals c squared. And we fill in the given values that have been given to us, which is 3 squared plus 4 squared is equal to c squared. And it's already given that we are going to square the 3 and the 4 and the c. So you can just add that on. So we're going to solve the equation. So 9 plus 16 equals c squared, and do a little bit more simplification to get 5 equals c. Because remember, we have to square root both sides to get the c just by itself. We're going to check the answer. And after simplification, 25 equals 25. So we're going to answer the question. The length of the hypotenuse is 5.